Hello. Good morning, everyone.
Good morning, sir.
Okay, so let's start. Yesterday, we have covered up to that part. We have done a hypothesis testing on this situation that, as per the country-wise, they have set up the factory for the different metal industry, mining, others. So, although we have visualized, and we, as a analyst, we have done this kind of observation that metal and mining industries are not available in all part of the different countries, and the same thing we have tried to solve. uh, Statistically, we find the p value is, we have created our null hypothesis, alternative hypothesis, then we have decided the alpha value, and we applied the z test formula, and we calculated the p value, and we found that our p value is more than alpha value. So naturally we are not able to reject the null hypothesis. This is more than alpha value. Okay, so if it is more than alpha value, that means this proportion of industry sector is we are not able to reject the null hypothesis. That means, okay. Oh, sorry, it's less than alpha value. It's not more than. It's very less. P value is very less than alpha value. It's 0.005 is our. So here our can write our p value is less than 0.05. So we are able to reject the null hypothesis because the p value is very less. It's 2.65 into e to the power minus 32. It's very less. So you can write here. Our calculated p value is very less, so we are able to reject the null hypothesis. Okay, so same things we can try quickly for the employee type by gender also. So the same copy paste we can do this thing, and we can calculate. Sorry, this one. Here we have done the country and industry sectors. So all fine.
We have just calculated the p-value for country 1, right?
Yes, overall we have just calculated the overall our observation.
But
That's
we have taken the country 1 only itself.
yes.
We have
I've given the variable name, na? The country one. I have considered here
got it.
country. Okay.
Okay.
Now the same thing we can try for the employee by gender also. This particular hypothesis testing is such an important topic that if you learn more, you will realize the more information is required. But it's an interesting topic, and naturally, if you will mention any of the statistical project or case study in your resume, believe me, it will a added advantage, because even the interviewers are looking for that kind of person who is good in statistics. Good in statistics means you can ask them, yes, I have done one case study, and also the tips I am giving, mention any case study, and you can take any reference from Google also. If any white paper publication is there, just take the reference, mention that publishers, some some universities, many universities are there who are doing this kind of hypothesis testing on different, like as one very that I had also tried in my class. That one is the toddler, sleeping toddler, means the baby who do sleep in afternoon. What is their sleeping pattern at night? Okay, because it's all depends on different the climatic situation. In some places, babies are sleeping in afternoon. In some part of the world, they are not able to sleep in the afternoon. So what is the impact on the sleeping pattern at night? So this is also one of the nice case study, but very interesting one. Similar, many things you can try, and mention at least 3 4 number of. If it is very small, just mention 3 4 number of case study in your resume. Then it will create a good impression that you are good in statistics also. No matter if you are not good in other part of the machine learning, but if you are good in statistics, na, the chances is high that many a sector will recruit you. Many a sectors, many a domains are there. Okay, but it's required little uh, practice also. Okay, so let's change here the employee sector. So in place of employee sector, we are just writing the employee type by gender. So let's write here gender. Employee gender equal to df dot group by, and here what we will do, we'll keep here gender. Gender is the column, and employee type. And then here again employee type. So after doing quickly all those things, we'll start our model building. Okay, and this all fine. Then again the mailed. Here we will write the gender, reset index, gender, and finally this one, the gender and employee type. All fine. So let's try here. Yes, you can name the season type by party by given employee type. So just name of the x-axis, y-axis is required to change properly. So okay. Now let's. So this is the just the copy paste. I have done nothing, just changing the name variables and print. So look here for the female, male. What is the situation of employees? These are the third-party employee. These are the factory employee, third-party remote employee. There are three categories are there: employee, third-party, remote employee, all those things. So we can calculate all this, and now we can do the hypothesis testing on this also, because as per the observation, we are finding the ratio of employees, type, gender wise, is not very difficult, not very different in each gender. Okay, like as look here, the third party male, third party female is not much difference, almost very close, little bit 2 or 3% difference is there, this one. And similarly we are finding the third party remote. Yeah, this is the little bit difference is there. Okay, so we can say the third party employee in each gender is almost equal. Third party employee in each gender, just like a third party male and female, is almost equal. This is our observation. Okay, and the third party remote employee is not equal. The third party remote employee of female and third party remote employee of male are not equal. Okay, this is the observation we have made here. So because the interesting thing, look, if you will use some automated tool, many things you will not able to learn. the many interesting how to interpret the things. So by doing this thing, you can at least see, you can try to understand what these images are indicating. So here we can simply write the observation that the third party, this is the third party, male and female is almost same. Third party male female is almost equal in the accident. They have been involved in the accident, no problem. And third party remote, this one is the third party remote. The genders are not equal. Okay. Now, if you want to do the hypothesis testing, whether this particular difference is statistically significant or not, so we can check this thing. We can check whether this difference are statistically significant or not. So whatever observation we have made, it's through the image. This is the visualization we are doing by plotting a graph. The same thing we can do through statistics also. So same approach is required. We have to create the null hypothesis, alternative hypothesis. So that means we are doing the hypothesis testing. So first is the, we will define our null hypothesis. Sorry, we have to define the hypothesis. Okay. So assume we are doing the hypothesis testing that the third party remote employees in each gender is not equal. Okay. The third party employees gender are not equal. This is our observation. The proportion of the means what kind of this is required, that employee gender. So this is the our own employee gender. Here it is the female, and this is the male. So we are finding a little difference here also, but not very high. Little difference. Okay. So whatever options you want, you can keep here. So just like suppose we are writing here. This is just, see this one. The permanent employee own employee, the value is 36%, and here we are finding 42%, and in this case we are 41% and 45%. No, there is also a difference, 23 and 13. So we cannot write not, it's the same. So this is, here we have to change the comment. Is the third party male female is basically it's not equal. It's not equal. Remotes are also not equal. Our own employees are also not equal. There is a difference of some 3 4 5% is the difference. Okay. And our own employee, the genders are not equal, the involvement in the accident. Okay. So let's make these kind of things that our as per our observation, we are finding the proportion of the own employee genders are not equal. The proportion of own employee genders are not equal, but the This is our observation as an analyst. But the null hypothesis will say nothing is extraordinary, everything is normal here. So the proportion of own employee, the genders are equal. They are saying. Okay. The same next, what we will do will decide the alpha value. Similarly, alpha value we have decided is 0.5, 0.05, and then again we will do the Z test and we will calculate the p value. Okay. So the same things last time we have done. We have created this mining country, shape, all those things. No? The same thing we'll do here also. That male count is the DF is 2. I don't know what is the name, DF1 or DF2 where we were working. So let me see this. Yes, DF1, no problem. So DF1 dot head, let me print here also if it is required. No problem. So DF2, we take gender equal to male. Okay, and we'll take it shape of 0. And similarly, female count, male count is the female count, DF2, here gender, here we will write female. Okay, and then we will see the employee type. So employee type means our permanent employee, that we will see. Suppose we are making on this now. So male employee equal to same thing. Whatever, if you want to check on the third party, you can just pass here third party. If you want to check on remote, you can pass here remote. So all same, it will be not any difference. Employee type is one of our, this is employee type. There are 3 categories are there. So now first of all, here we are doing this experiment on this employee. Okay, so employee type equal to employee.
So that type should be small, sir. T.
Yes, correct. So anyone in the class who has done this kind of hypothesis testing during their session when you were covering the states in ML, okay, anyone in the class has done this kind of experiment?
So I never did it in the coding format.
Okay, because learning just as a theory part is no use, na? It's no use. That yes, yeah, I know that hypothesis. If it is more than this, then we can reject, select. But just try this thing. If you are doing on any these kind of things on any of the case study, it will be real learning. Theoretical part you can very easily you can find on Google. Just write in the Google. Yes, what is hypothesis testing? Multiple PDF file is available, but it will not clear your doubts. So this practical is required because it may be possible that today if you start applying for the job, you are not getting the job right now. But yes, after 2 months you will get the job. But till the period, you should enhance your skill. You should enhance your knowledge base. Okay. So just learning the same things again, whatever you have covered in the class or theory part is no use. It will not work generally. So this is the gender is one column also we have. Yes. So we will See here, gender dot value counts. The same thing for the female employee also. For the male employee, this is the situation. For the female employee also we can write. This is employee type, employee, and gender dot all those things equal to all fine. But here we have to write one. Yes. Now just run this. There is no problem.
Sir, it should be DF1.
Oh. Okay. Now the same thing, we'll copy paste the hypothesis testing. Last time we have done these things. You have to copy. This is already we have imported this proportion, and the same line of code is there. Same line of code. Only you have to change the values. Okay. Then you can get these particular things. No problem. Just let me write here also again. So now we can do the calculate the hypothesis. Do the hypothesis testing. Okay. The same thing we'll write. T statistics, p value. So it will return us T statistics and p value of proportions, jet test that we have already imported, and here we will pass our male employee. Okay, let me make it capital, then it will look good. Sorry, male employee and female employee. Jet test, male employee, female employee, and then here we will write our male count and female count, male count and female count. That's enough. It will return us the t value and p value. So just run it, and then you can take the print of this. So print, no problem. Just write here t statistics. These things you can do. And p value. So let's see whether it is less than 0.05 or not. So we are finding our p value is 0.5745. It's more than alpha value. So p value is more than alpha value, that is 0.05. So we are not able to reject the null hypothesis. If you are not able to reject the null hypothesis, that means there is enough evidence the proportion of unemployed, the genders are equal. So here we are finding it's not equal, there is difference. But as per the hypothesis testing, because hypothesis testing it's always gives some kind of generic calculation. That doesn't mean that suppose you have developed a particular medicine and it has not worked properly on Mr. Ram, one patient. So that doesn't mean that medicine is not success. It will take the conclusion on on the population, So whatever we have concluded, we are making our all this descriptive analysis on the sample, and we are making the interpretation on the population. So this is all hypothesis testing. We are doing this experiment on this particular situation. Okay, but in the mass level, if you will think as the population level, in the generic, whatever, suppose you want to create an opinion, you want to write some kind of a statement, then here our null hypothesis, we are not able to reject the null hypothesis as per this. So on an average, it's the proportion of employees, our own employees and genders are almost equal. So almost equal, we can say this thing.
Sir,
Yes, please.
can we say that in this case that we are 95% confident that proportion of own employee genders are equal? Is this how we draw the meaning?
Yes, correct. So
We are
here
95% confident.
95% confident. Like suppose we have plotted this particular thing now, and if it is coming under this is the confidence level. This shaded area is called the confidence level, and whatever value you are finding in, this is called the confidence interval, and this is the center. Whatever is there, the point estimate. Okay, so in that way also you can make the interpretation, right?
Sir,
Okay, so yes, please.
I'm not able to understand the last line of the code. Not
This
this one,
one?
yeah. This
This
one,
one?
because yes, in the last p-value, we had two columns and we took the length of the last column, last one of the column before this.
Yeah. Just make a print. You will get the idea what is there, na? 1 minute. So mail count. Suppose I am just writing here. I'm not passing here save. Let me make a copy. So why this is okay? Save. We have to check, right? What is this showing? 403 and 19. So basically, how many number of mails are there that we are interested to know? 403.
403.
The same thing will calculate here also.
Yes.
Okay. And that's because we are creating the proportion. That's the important thing. Na? We are creating the proportion.
Okay.
22, only very few females are there. Okay.
Yes.
That's the reason.
Okay.
So let's do one very interesting thing. This is the our NLP. I'm not covering many things because of that shortage of time. So I will give some assignment also. Word cloud. Okay. Word cloud. CLOUD. So word cloud is a very nice visualization because we are doing the visualization. That's why I am continuing on this only. Word cloud. So I hope I have imported this thing. Word cloud is there. Word cloud, the NLP. I hope I have imported naturally somewhere. The other things where we have imported now. This is Seaborn, Holops, NLP.
Yes, sir, we have imported.
Imported, na? Okay, no problem. Let's continue. So word cloud. So let's write the word Word cloud means it will read the text, and whatever the important points are there, it will highlight it. So it is also one of the nice visualizations. So word cloud equal to word cloud in bracket, whatever the width, all those things, width, height, these things are required. So you can check here also. There are many things it will ask to pass in the word cloud. So basically we have to fix the size, all those things. Okay. And if you want to pass the stop word, you can pass the stop word also. And then you have to define the particular column, from which column we want to apply all this thing. Okay, which column we want to apply. So dot we will apply this thing dot generate. I will pass these parameters later on. First generate it, word cloud generate, and whatever text it will print, I just want a space between the text so that we can read properly. Dot join, and here we will pass our df1 and this column name from where we want to extract. So this column name is description. Description is the column. So let's see, description is the also column. Description processed. Let's write this one, description processed. So at the time of accident, what they have mentioned, all those things. Let's do the experiment on this. What are the most important words they have used? So I will write here description processed dot values. Okay, I hope it is enough. Then we'll set the some colors and all those things and size. Only this much is required. I hope it should work. Let me try. So after doing word cloud, I have created, and fix size also. Okay, plt dot im show and word cloud. So word cloud is not defined. What is word cloud? Okay, this is the things. Now we can set the size, all those things as per our requirements. Let's make the size. So it's very simple, it's not complicated. Look, what we have done is very simple thing. We have just dot generate. We want a space between the words I have created, and join this I want. Simple. And here lots of options are given. Many options are given. Set the width, height, margin. By default it is taking 400 and this. Okay, so let's make it, I will change it little bit. And background color is also there, that also you can select. Color functions are there, stop words are there. If you want, you can use the stop words. Stop words means it will not use the general words, is that these things it will not use. So you can change all those things whatever you want accordingly. Okay, and so let me change some little bit, then you can practice later on. So I'm just writing here width equal to 1200, some large image. Height equal to 1000. Make it less because we are not able to see on the screen. And background color is all fine, no need to change. If you want to change some kind of color map, this is also option is there. Color map, you can write some rainbow. Rainbow is one option. And if you want to write the size of the font size, minimum font size, so this is all right. There is no, by default it is also taking good thing. Okay, if you want to write the length of the, look here, so almost it has injuries, you're able to understand the move right hand, these things are there. So simple, you can just change it. So these are the operation, active, cause injury,
Hi, sir.
moment. Yes, 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 please.
We have done stemming. That's the reason the spellings are not
Yeah,
coming up
correct,
completely, right?
correct,
Okay.
correct. This is the reason. Okay, but this is also one
Okay.
of the way we can do the word cloud also. So I
Mhm.
am actually from Monday onwards. I am starting this particular class, and that's NLP and deep learning in the evening. So if you will join this, so we'll cover this thing in detail there,
So,
also in the
what time?
class.
8:30?
8 to 10 evening, 8 to 10.
Sure, sir.
Okay.
So how will we get the link?
Just coordinate your just contact your coordinator and ask her or him that evening batch I am starting this particular thing. So look,
Sure,
the
sir.
interesting thing is that although they have asked me to cover the basic of NLP deep learning, but I don't feel satisfied just covering the basics. I will try to cover some advanced topics also. Some things which is very challenging in NLP, that things I will try to cover, so that in the interview, if they will ask something, you should not feel ashamed that I have not heard the name of this particular topic. You can say yes, yes, yes. I was expecting this question. I know little bit about, because those things are challenging in NLP. There are sentiment analysis also. If time permits, I will do the one case study on the sentiment analysis also. So these all things we'll try. Yes. So there are many kind of other graphs you can plot. So I'm just writing here because now next is we will start our uh, because it's already 1.5 hours is definitely required for the model building also. So
Sir,
assignments, yes, please.
sir, why some fonts are shown in the big, I mean, of the bigger size, but some are shown smaller?
Because when whatever fonts are, number of times it has repeated, that's why some fonts will be bigger. It will highlighting that yes, this is the most important area. Here we are working on accident and all those things. Suppose you can do these same things on the sentiment analysis of a stock price, and you can plot a this thing kind of word cloud, so you can get the idea which stock, what's the reason, all those things. So the bigger the font, important the word. That's the meaning. Bigger the font, important the word.
Okay, sir. Yeah.
Okay. So I am just writing that you have to try assignments here. First, you can try the accident label by gender. Label by gender, that we have not done. The accident type 1, type 2, type 3. Okay. Potential accident label by gender, that also we have not done. Potential accident label by gender. And there are many you can try. Potential accident you can try. Employee type also you can try. Accident label by gender, accident label by potential employee type.
So we have to create this word cloud.
Yes. No. This I'm
Yes.
asking to assignment for the uh,
P-value and
bar plot, all those things.
okay, bar P.
Accident label by employee type. Employee type, you can also try this one, because this part also we have not done. Accident label by month, day, week, weekend. Okay. By month, day, season, weekend. Same thing, potential accident label by these things. And what else? Yes, this is enough. If we are doing up to, in NLP also we can do lots of things. NLP, like as to create the number of times a particular word is uh, a unigram word, bigram word, okay, trigram words. Means unigram means one letter, bigram means two letter, trigram means three letters. Like as left hand finger is the trigram, okay, and left hand is the bigram. So how many times this word has been used when you're finding the, and just like as left is the unigram. So we can see, we can do the NLP for this column also in detail examination. Description, how many times, so you can easily understand many things. Yes, this is the most of the time the left hand are injured in the accident. Most of the time this part in the, in trigram you can find that shirt sleeves, okay, shirt sleeves has caught between these particular things. So you can ask, okay, left arm uniform, right arm uniform, acid worker, acid worker apron. So by finding all these words, you can find these words and you can take some kind of action. You are finding apron is mostly involved, the left hand apron. So you can ask the vendor who is manufacturing that particular apron, look, your left hand apron side is little bit loose or something. So this kind of basic ideas we can get, okay, loose balance something, okay. So these words, whatever, whenever the accident will happen, so the investigating committee will always write the complete detail, just like as police investigation, they write all the things na? In the police investigation they write all the things about the crime scene. The same kind of things you can do on a data set related to police investigation. You can do lots of things by looking at this description of the event. Here you can plot a word plot, this word cloud. You can find some kind of graphs, you can do some kind of observation. So that's the reason that forensic science is always also very much interested to involve this and data scientist, data analyst, AI person in their team, okay. The CBI inquiry persons are also looking for the expertise of AI for the, to apply their knowledge in the bank account forensic, okay. So these all many things are there you can do. So these are the basic assignment you can complete. And for the unigram bigram I'm not asking because that part I don't know whether you have covered or not, okay. So the next is the sentiment trend also you can do. Now let's start the modeling part.
Hi, sir.
Yes, please.
Sir, you have imported the library SHAP as well. So, when do we need
SAP,
to use
SAP,
it?
SAP is widely we will use to find the feature importance, visualization
Okay,
of the feature importance.
okay, okay.
So at that time we can use. So model means uh, just do this thing, okay. Modeling. So what we can do, we have the, this is our data set df1.head. Now we will do the model building here. So we have date, country, local, all these things, because we have not worked right now. Na? Many things are there, lots of different variables you will found here. So let's start. So what are the different features and df1.info. Okay, so luckily we don't have any missing value. It's no problem. We all having 425, 425, so there is no problem. But there are many columns are there which are object. One date is there, date time, that we have already extracted all the information from date in the day, month, year, weekend, week of year, season, that already we have done. And in the interesting thing, we have calculated the description sentiment score. This is the very interesting thing we have calculated, and from this particular description processed. And this is the both are the same thing. New score and all these things are the same thing. So no problem. So if you want, we can create some new columns, further new columns also on the base of the that with the help of this NLP TF-I DF columns. We can create few new TF-I DF columns with the help of NLP. But let's don't go in that direction. So let's calculate first the how to convert this object variable to the numeric one. This part is very important. First we'll do this thing, and then our all data will be in one format. Then it will be quite easy. So simply what we do, we just write one by one. Na? Most of the time people are doing like that. Suppose they are writing S type approach, fit transform. Okay, but what we will do, we'll just keep all this object variable in one variable. That is the our categorical column. So let's write here categorical column. Categorical column equal to df. Let me make a copy of this thing. It is better. df2 equal to df1 dot copy. I have done this copy. Okay. Now cat column equal to df2 dot how can you get all these variables in all this object type in one variable?
Dot select underscore d types, then we take include
Select
equals to
underscore d types. Okay, and here
include
we will
equals to
write include equal to
object.
object, capital O. So it will only give the whatever the columns are object in this, it will come in this particular categorical columns. So let's run it. And if you see cat calls dot head, so only these categorical variables are there. These are categorical, all are categorical in the cat call. Now we just want the column name. We just want the column name, so that we can apply, we will apply this thing, our one hot encoding, label encoding, whatever you want. So better we'll apply the label encoding only. So I am writing here cat columns equal to cat call. You can write this in one line also. Columns. If I will write the columns, it will give the only columns. So cat columns. These are the categorical columns, categorical variables. Okay. Now what we will do, we will simply apply the, suppose you want to apply the label encoder, we want to apply the label encoder. Okay, so just write simple from sklearn dot preprocessing import label encoder, because I found many students notebook, they are doing one by one. Country they will convert, local one by one, 20 50 line up. Suppose there are 200 number of categorical columns, 200 times I found they have written 200 times. I don't know from where they are developing this concept, but here we can simply do it. So df2 cat columns equal to df2 cat columns dot apply label encoder.
Sir, can't we do by the loop?
Yes, it will be more easy. Just wait a minute. It will be very easy. Fit underscore transform. That's enough. Your job is complete. You can check df2.info. See, okay, when you are able to solve a easy problem easily, try that approach. Don't try a complicated approach. This is the indication that you are an intelligent person. If you are able to solve a easy problem easily, try that approach. Why we'll write some line kind of loops and all those things, or one by one we are trying? Simple. I have just taken all those things in one variable. I passed here. Complete. Okay. Now, what next is required? So first, let's work on the, because there is no problem, and we can drop few of the columns, unwanted columns, just like a date column is not required. This is not required, date column, and let's start this thing. So we have basically two dependent variable here. One is the accident level and one is the potential accident level. Okay, so we have two dependent variables, accident level and potential accident level. So we will work one by one. We cannot use both the independent variables, both the dependent variables, and we will solve. It's not possible. Yes, it can be possible in TensorFlow, but that code is little bit complicated. That's the reason no one is taking this particular step when they are teaching the TensorFlow in the deep learning. How to write a function so that we can get the output of two dependent variables, two results, two output at a time. Okay, but here in the supervised machine learning, we have to take care of these things individually, one by one. So first case is our case one. Let me drop this particular column. This is not required. Date column is not required because that already we have extracted. So first let me drop this thing. So df2 is equal to df2 dot drop that date column, date, x is equal to 1, because that column is basically not required. We have already extracted all the information. So case one is
Sir, why we are
Excel,
dropping the date column?
because that column is not required. No, we have already extracted this information.
Yes,
Day,
exactly.
weekend, all those things
Day
we have
weekend.
already. So it's not
Sir, we
required.
can also drop new score, right? Because
Yes. That also will drop.
new score and descriptions
Description.
both are
Yeah.
same.
So new score we will drop. Correct. So no problem. Let me write again. Otherwise it will give the error. So these all are the basic things you can do the in regular practice. No? That the same things you can do. That how to next is the depending independent variable, all those things find out and all many things. So case study is the first accident level. So let's see df2 of accident.
So,
Yes, please.
yeah. So here just use the label encoder. If we use the label encoding, it will give the number as a series 0 to n of the numbers. So it will not affect our model building.
Do you mean to say this is our categorical column, and suppose we have our one option is either you can do the label encoding or you can do the one hot encoding, right?
Yes.
So in the label encoding, it will just change this variable in the same column. Okay, and in the one hot encoding, it will create the columns. Whatever, suppose I am just talking about this particular column, this is the a new column, so it will create for many columns for this, right? So if you apply the one hot encoding, it's always good, but it will create some kind of a complicated data set. It will create a complicated data set. Okay, so you can try this thing also, one hot encoding, and when we apply this thing, you have to drop the dummy variable also, no problem. But yes, number of columns will be increased. Right now, suppose we have some 50 columns, so because there are various, you can check here, there are in our data set we have various categorical variable was there, industry was 3, here some 5 6 are here also, 2 here also, 3 critical also, you will find various this columns will be there. Okay, so it will further increase, but here at least anyhow, here we are finding few number of whatever this balance is available, that only. Okay, so you can try this also, but it will increase the number of columns. It will highly increase the number of columns. Okay.
Got it.
Sir,
So
adding to that, I had one more
now-
question.
I think this is also not required. Description is also not required.
Description and description pre-processor is also not required.
Yeah, this is also not required. This is not required. These two things. And critical, all fine. It is okay. So let me drop this also. Description and description processed.
Okay, but sir, if we use the label encoding, so it will assign the number to the n numbers of a time. So if we use the OLS method, if it is a regression problem to check the p-values, so it will not affect to that, because calculation is on the numericals and it is a high value, so it will affect the value.
Yeah, definitely. But here what happened, that after doing all those things, you can do the scaling. So naturally, after doing the scaling, many a problem will solve. But it is always true that our machine will understand if you're applying the level encoding and one particular column is there where 10 or 10 type of categories are there. So if you'll apply the level encoding, it will be 0 to 9. It will assign 0 to 9. But if you will apply the one hot encoding, naturally nine columns will create, and although it will create some kind of sparsity, 0 will be very high in number, but every observation or every these rows, only one place 1 is there and all other place 0 will be there. So naturally our machine will not give high importance to any of the number. 0 1 is all close, but here little machine can give more weightage to this 9 number rather than to 0. This is the advantages. Disadvantages are also involved with one hot encoding, level encoding. But here the problem is it will increase the number of dimension. Okay, so this will be little computational time will increase. But yes, naturally, if you will work on the real world scenario, try to apply the one hot encoding. You will find a difference of approximately 1 to 2% performance difference is there naturally. But any kind of data set you can try. If you apply the one hot encoding, around 1 to 2% or 3% performance is better rather than this.
Okay, like, but sir, I was just working on the data set. They use the one hot encoding, and it has created the 235 around columns, and it was earlier the 75 column.
Yes, correct.
And I use the VIF for OLS technique. So more than means half columns are the more than values of the 5 in the VIF and 0.05 in the OLS. So we have to drop in one by one, or can be done by only one code if it is coming like that?
For the VIF, you are finding there are lots of values are there, na? Or suppose you are finding in the in this also correlation matrix. In the first of all, better to check in the correlation matrix. In the correlation matrix, suppose we have 500 number of columns. Let's take the example. We are working on a data set and we have 500 number of columns. So in the matrix, this 500 rows will be there, 500 columns will be there in this particular matrix. Sorry, my writing is not good. I have never practiced how to write because if I concentrate on that partner, my thought process stops. So that's why I always use my mouse only. Okay, so 500 columns are there. So naturally, if you plot a correlation matrix, we have 500 here. Okay, 500, and here also we have 500. So total we have 2,50,000.
Yes.
2,50,000 number of small this. When you plot a heat map, you will not able to see anything.
Yes.
So how to solve this problem?
Variance inflation factor.
No,
Yes.
here also I have covered in my class in many projects I have done. One project I have covered the that's power plant, hydraulic power plant, where there were some 450 numbers of column was there. And also I have covered one project that is the ultrasonography manufacturing. 540 number of columns was there. So you can ask how any your coordinator to give the access of that project. I have handled this thing. It was very interesting one, very easy approach. How to find the multicollinearity when you are not able to see anything here?
That is, we convert it to lower triangular matrix and
Yes,
then
correct,
to
correct, correct,
more
correct.
than 0.8 if it is
True.
coming.
I have applied that true function. True
Yes,
function
yes.
you can apply, and very easily, very interesting. Because this thing will found the graph will be like that. Na? Only text will be here, and here I have just passed the null value and simple 2-3 line of codes. All these high correlated columns will be come into the one variable. Just use that particular variable name, drop it. No matter there are 50, 60, 100. Just like as here, whatever approach we have taken, all those things in one variable and we applied same things. We'll write the line of code in one variable name. You will get the column names which is more than 0.9 on whatever benchmark is there. You can handle it. So for this, the same thing, if you want, you can try for the VIF also.
ओके एंड सर अगर आपने अभी बोला कि हम लेबल एंड कोडिंग का यूज कर सकते हैं और इस बाद में स्टैंडर्डाइज करके उसको चेक कर सकते हैं बट सर जैसे कि आई वाज आस्किंग अबाउट द ओएलएस मेथड विल नॉट वर्क ऑन द स्टैंडर्डाइज्ड वैल्यू so it is
OLS method
okay
will not work means I don't understand.
sir because we just use the standardization digits in our OLS method means after feature scaling we use the OLS method, so it gives the very worst results, like 0.3 something 4 below 10s. So
No,
most of the times I just
OLS method always give the same result. Now, suppose you are working on the regression problem, OLS, I hope you have applied for the regression, no? So it will give the almost
yes.
same result as the whatever you are getting in linear regression. I don't know
No,
what
sir.
approach you are doing. Are you adding the constant or not in the OLS?
Yes. I
Yes, or
added with the BIF also and OLS also, but the result is very pathetic. It is approximately below 10.
no. So
And the
it
two
depends. It
model
depends.
management.
Sometimes if you are not finding good result, na, then you have to apply some tree-based algorithms because OLS is also one linear regression approach it is taking. So you can apply the tree-based algorithm. It's not a problem. So
Okay.
here what we are doing in the, so first of all, we are just working on accident level. So this is our target. Our Y is DF2 column accident level. Second level and X.
Sir, this is a classification problem, right?
Yes, this is the classification. X equal to df2 dot drop, and here we will drop this all unwanted. First of all, we have to drop the accident label. Then again we will drop potential accident label. And also these two columns we don't require, that you told na. This is description processed and the new score, and description sentiment score is required. Okay, so we don't require this thing. Description process we don't require. Description also we don't require. But where is this particular column? Why it is? Oh, okay, here. Here we can check. Yes. Description process we don't require, and the description. So let's drop these two columns also, because we have already extracted this na, the sentiment score value that we will use. And description. These all things we don't require. So here we'll pass x is equal to 1. Now in x we have all the independent variables, and y we have dependent variables. Okay. So after that, simple, you can create your this trend is split. Okay. So x trend comma x test y trend y test equal to trend is split x y random state. If you write the test size equal to, so our data set having not high number of observations, so we have how many number of columns, rows are there? There just 425 number of entries are there, only 425. So this number, whatever these things now, they are 20%, 80%, it's all depends how many number of observations you have. If you have millions of observations, it is not necessary to keep 80-20 ratio or 90-10. No, millions of observations you can keep 95-5 also, 95-5 also, even 99-1 many times you will find. If you have 10 millions of observation, 1 CR data are there, na, even 1% is enough to check the testing, to check the evaluate the performance. So maximum data will pass in the training, the chances will be better. Okay. So it's all depends on an average. Suppose we have 1 lakh number of observations, so we usually we keep 80-20, 90-10, it's all fine. But here the data set is very small, so 80-20 is all okay. So that's why I have passed here test size equal to 20%. Okay. Random state, (42) most of the time people are writing because I think it's related to some serial or some kind of book they one author has written. They have used this random state equal to 42. That's why there is no other specific reason. So anything you can pass. So whatever random state we are writing, suppose I am writing 100. If you will write also 100, so naturally you will find that in the X train the observations are same whatever observations in my PC I am having. So this random state, whatever random state you will fix, it will the randomness of the creation of training and testing will be not there. Okay, so it will permanently fix. Okay, these things, this number of observations we required. We cannot say by chance we are getting a good result, because and when you evaluate the model, if you have not passed the random state, na, every time it will take a new, it will create a new set of training, testing, all those things. So every time a little bit difference in accuracy will found in performance. So optimization will be difficult for you. That's why we are passing random state equal to 100. And one more thing is there, stratify. Stratify, let me ask someone. Yes, Mohini Goel. What is the meaning of stratify?
Yeah, sir. Yeah, stratify is used to balancing the data. Means not balancing. If our data is imbalanced, so there is a high possibility that our data as in the target variable take only the one type of
Yes.
a value and not take the
okay, right.
others type.
Correct. So what should I write here? Stratify equal to true, false, X, Y, trend test. What should I write?
Y.
Okay, so we should write here Y, whatever the target variable name.
Sir, is it something like solving a issue of overfitting?
No, it is the stratify is not help for the overfitting, but yes, it will help us to read the all the classes.
Okay.
So it's the sampling approach. Stratify is the one of the stratified sampling approach.
Oh, sir.
Sir, in the stratify, I have one question. If we just use the stratify in the classification problem, so there is a no need to balancing of data, or mostly time we can use means, or every time we can use the stratify, or it is a some assumption on
No,
the position we can use on the
it is always better to use the stratify, but balancing is data is something else. When you are not able to find a good result, na? So although balancing is data is not a good thing. Okay, balancing a data is not a. I have not imported trend test split. So from where we have to import? Can anyone tell me? From sklearn
model selection. Yeah, model selection.
dot model selection import trend test split. Yes. So what is this expected? Too many values to unpack. Expected 3.
Then after the white train, we underscore train.
X train, X
It should-
test. Y
where
train.
should-
Oh, okay. Yes.
come up,
Yes.
come up.
Y train, Y test. Correct. So when our data set is imbalanced, so many people apply the approach. They very first they will balance that. They balance the data. Okay. It is the habit of some people I have found that if our data set is imbalanced, the very first step they have done balance the data. It is the really not a good idea. Balancing imbalanced data is really is not a good thing. Very difficult to make any kind of prediction. So, but balancing is also not a right solution basically, because anyhow we are creating some kind of synthetic data or some kind of duplicate data. So it's not a good idea. Rather than balancing, first of all, always try to build the model, whatever the original data available with us, try to use some different algorithms, try to use some kind of hyperparameter tuning, some kind of optimization approach, regularization approach, whatever is possible. Okay. So in real industry, they don't do balancing immediately, because in the real world environment, the model they get only the imbalanced kind of data when they will use this model. Okay. So first try to solve this problem without balancing. There are various approaches are there how to work on the, you can, it's a very good question. You should search on the Google also how to work on imbalanced data set. So whatever we teach in the coaching in the classes, we always try to use some kind of shortcut approach. Even I never appreciate students to do balancing immediately. It's not a good thing, na? But many a times you will find that people are saying balance the data. So after balancing, naturally your result will be better. So there is no further question student will ask how to improve the performance. So it is one kind of eye wash. Okay, it is one kind of eye wash if you are balancing the data. And many a times what people do, they balance the entire data set, X and Y. So this is the blunder mistake. If you will balance the entire data set, so there is no need of further learning. You just immediately get all the results, very good results. So you are eligible for a Nobel Prize. Whatever complicated data set you have, in just half an hour, you are able to give a good result. But that model will not work in the real environment, because in the real environment, you will find the imbalanced data set. So even in worst scenario, you are balancing the data, only balance the training data set, never ever the testing data set. No matter, you will not find a very good result. Your result will be only, just take the example, if you are balancing the entire data set, your result will be 95%, no problem. And if you are not balancing the testing data set, So your result can be 80%, 85%. Okay, but this is the real. So we are talking about the balancing the data. So it's always not advisable to balance the data immediately. So first of all, we should try to build the model without, if you are not finding good result, then later on we will see how to do things. So I'm just using a basic algorithms right now. This other algorithms you can apply. So sklearn dot ensemble import random forest class. So basically it is a multi-class classification. Look, there are in the accident level, there are 1, 2, 3, 4, 5 classes are there. One is the 74%, 9%, 7%, 7%, 1%. Class 4 is just 1%. So it's very small proportion is of class 4. So it's not always easy to get a good result if it is a multi-class classification. Okay. Yes, we can check p value also if your data is normally distributed or not. We can do the hypothesis testing to check whether the data is normally distributed or not. Statistical approach we can follow. Random forest classifier, bagging classifier. Okay, so what is the difference between the bagging and random forest classifier? Can anyone tell me? What is the basic difference?
Bagging isn't the part of an assemble technique, and random forest classifier consists of both bagging and bootstrap.
No, I'm talking the bagging classifier and random forest classifier.
Kube, out of bag.
Out of bag is available in both the cases.
No, it's available.
Yes, it is available in bagging as well as random forest also. sklearn dot ensemble import random forest classifier bagging class. Why this error is there? Cannot import random forest
The
classifier.
spelling is not right.
Oh, FOREST. Yes, what is the basic difference between bagging classifier
It
and
is
random forest
mainly
classifier?
on base estimator, sir. Base estimator for random forest is decision tree.
Correct. Okay.
But for bagging, it is not.
Bagging, what is the base estimator?
Cross validation, sir.
Yes.
Base estimator we can change, sir, in bagging classifier.
Yes, in the bagging classifier we can change the base estimator.
Base estimator, but in random forest it is fixed.
It is fixed.
Decision tree.
And what? Right. And any other difference? In the bagging classifier, when you select this thing, that features, when you select the feature in the case of random forest or bagging classifier, suppose you have selected the default is the SQRT, square root features. By default it is there. So whatever number of columns are there, it just takes the column by selection is square root of that. Suppose 100 columns are there, so 10 columns by default it will take, by randomly it will select. You want to cross check this thing, so suppose you just pass the bagging, the number, the feature and features equal to 3 or 2, whatever. So the root node, whatever the column it will select, in the case of bagging, suppose it has selected the column number 3 and 4. Okay, so all the sub node or the child node will only continue with column number 3 and 4. So you will see in the tree, the entire tree has only the column 3 and 4 in the case of bagging. Okay, but in the case of random forest, the root node, suppose the root node has randomly selected the column number 3 and 4. So in the next splitting of the node, next child node, it will again go back to the data set and collect the two number of columns, whatever we have decided. It can be 1 and 5, it can be 6 and 7, it can be 3, 4, anything it can be possible. So every node creation at every split in the random forest, it go back to the data set and it will collect the columns again. That in the general terms, as a layman, in the random forest, the children are not happy whatever decisions their grandfather has taken. Okay, if the grandfather has accepted that decision, no problem, we will work only on column number 3 and 4. This grandson will not accept it. They will say no. Again, we will go back to the data set, and you have assigned in the code that we can select two number of columns randomly. So I will select two number of columns randomly. But in the case of bagging, the grandchildren will follow the whatever decision the root node has made. So in the entire tree of the bagging, you will only found the two column, whatever the column the root node has selected, 3 or 4, it will be available in the entire tree. But in the case of random, it is not. So in the random forest, there are lots of randomness. In the bagging, the randomness is not high. This is the reason most of the time our accuracy or our performance in random forest is better than bagging if you are using the base estimator as decision tree. So this is the basic two difference. One, you have told correctly that base estimator we cannot change in the case of random forest, but in the case of bagging we can change, and this is the another difference.
Sir, we can also talk about overfitting, right? In random forest, random forest classifier is prone to overfitting, but bagging is not, because randomness is high in random forest classifier because of more number of columns, as you said.
Yes, but bagging you cannot say like is because this overfitting problem is solved by the bagging concept. Bagging concept is different, na? Bagging
Yes,
concept is how it is splitting the subset of data, okay, bootstraps of data, and then each and every weak learner has been assigned to one data set, and then jointly ensembling the decision on the basis of voting approach, and they are giving the solution. So it is the concept which is helping us to overcome the overfitting problem. Okay, but you cannot distinguish this. The bagging is bagging cannot help in overfitting. Bagging and random forest, both concept is useful for the overfitting problem. So let's define the random forest classifier. And simple, this next step you all
Sir,
know very well. Yes, please.
yeah, sir, as you before said, we just use the balancing of a data with only the training data set, not testing. So
Yes,
first we just split the train test split, and after that we apply the balancing data if
correct,
we are
correct,
just doing the balancing data.
correct. Okay, so you can build this model with your different approaches also. I'm just covering the basic things.
Sir, isn't it necessary to provide the other hyperparameters?
Yes, hyperparameter tuning you are asking, na? I
Yes,
have
sir.
not passed here, na? Yes, you can pass some things. I am just using the default one. You
Okay.
must pass whatever intelligently as per our experience. What should be the all those things required. So these
Okay,
things
sir.
is required to learn properly, because I am not passing assume. I am just using an estimator equal to criterion equal to Guinea. These all things. So if you
Understood,
want,
sir.
you can change this. This I was talking about the
Maximum features.
by default it is the square root. You can pass 3, 4,
Square
and
root.
so there are many things are there. One is the CCP alpha, that is very useful for the this is growth of the control, the growth of the tree. This thing also.
Okay, sir.
So you can read all those things. Definitions are written here. What is the meaning of all different? Because many times in the interview they expect that you should explain these things. They ask the intuition behind the uh, parameters and which condition, which parameter will work. So this you can develop some kind of idea also. Okay, let me first do this
Awesome.
thing. YRF predict equal to RF dot predict. So X test and confusion matrix we can pass Y trend comma YRF predict. And similarly we can do the classification report also. Why this is found input variable with inconsistent number of sample 34085. No, what I have done, I have calculated, I have done on the X test. Oh, here I have to write the Y test. No? So overall this is not a good model. It's not, because it is not able to, it is just able to identify one class. That's very easily in the multi-class classification, and just see in the denominator. So for the other class, it's not able to identify at all. Only it is able to identify the class 1. Okay, you can cross check this thing in the classification report also. So look, only it's working fine for this particular class, and even it is for the other class, it is not able to identify even, because the reason is our testing data set, these are very small number of observations. Look, 2 number, 6 number, 6 number, 8 number, very small number of observations are there. That's the reason it is not able to identify also. So let's apply some other algorithms also. We can try some algorithms like as XGBoost classifier also. XGBoost classifier also you can try, and many times this is the highly imbalanced, so it will not work. You have to apply some kind of hyperparameter tuning. So let's apply XGBoost classifier. Let's see the result from XGBoost. XGBoost classifier, XCB, XCB classifier. Xtrain, Ytrain. So you can try all other algorithms also. Okay. So in the XGBoost classifier, again we have lots of
So
parameters are
what
there.
is this XG? Because we never heard of it.
XGBoost classifier is also one of the algorithms. Na? Let me write here. So XGBoost classifier, XGBoost is there, classifier, regressor, both are there. Okay. Then cat boost is also there. Okay. XGBoost, cat boost, many classifier, many others are there. One is the same cat boost is there. So there are these all are not in the in our sklearn. Okay, but you can apply, you can simply import these things easily. You can import, you have to install XGBoost, cat boost. There are, I'm not recalling the name, 1 2 are also there. Light XGM, light GM, gradient light XGM. Okay, so these all are, you can install, pip install, you can just Google it. XGBoost, cat boost, light XGM, These all are, this is the amazing one. When most of the time it works very fine. So simply, if you are installed it, then after this line is code is required after installation pip install. So many times it works very fine. XGBoost classifier also. So simple. Suppose we have this fit. After fitting, again the same thing is there, but I'm not sure whether it will give the good result or not. Again, I'm doing the prediction because I'm just using the default one, default parameter XGB predict. Oh, mistake. Here I have to write not the random forest, but the XGB. Okay. Now see the confusion matrix. What is the situation here? I'm not using the this accuracy score because there is no meaning to check the accuracy score in the highly imbalanced data set. Still, it is not able to give a good result. Okay. So if you see in the classification report, same situation. Our recall value is 92%. Here it is random forest is better than the XGBoost because recall value is 100%. Okay. So the same things you can try some other algorithms also. So let's try some 4 or 5 algorithms all together. So from sklearn, we can try this gradient boosting classifier, AdaBoost classifier also. So we can write here also, we can import because these are belongs to our this family. Ensemble learning. So many others are there. Just import those also. Random forest bagging already we have done, no problem. Gradient boosting classifier is there. AdaBoost. So although we can get some idea by looking at the data set, whether it's the parametric, non-parametric kind of things, whether which algorithm will work. But in the reality, it's very difficult to say which algorithm will work. It's all depends on the data set. So a trial and error approach is always required. Okay. So you cannot say this algorithm will work. I will use only these 3-4 algorithms because using algorithm is not very complicated. Just import it and you can fit it. It's not very complicated. Okay. So if anyone will ask even in the interview how you will decide which algorithm will work, so you can say yes sir, it is possible if our data set is parametric, so naturally our logistic regression will work fine if it is a classification problem, but it is even not guaranteed. But if it is not non-parametric, means not normally distributed, so naturally logistic regression will not give a good result. Then the whatever options left with us which will work fine, we cannot say with 100% confidence that yes, this algorithm will work fine. So we have to apply the trial and error approach. This is the only option. But yes, that parameter tuning, you can say yes that this parameter tuning will help us. So from tree, import decision tree classifier and logistic regression. Let's import the logistic regression also from sklearn. Linear model. There are many other algorithms. You can try KNN, SBM, Nebase also you can try. So I am just using few of these. What happened? Gradient boosting. Now just a simple write a function, and then we will use all the algorithms. So random forest already we have applied, no problem, we'll not use it. Bagging, if you want, you can use the random forest in the bagging. Logistic regression also, we can write weight balance equal to class weight equal to balance. So many times logistic regression give good result. So let's do the same thing, no problem. So I'm just already, I have already initialized it. Let's do it quickly. The random forest. One thing. So gradient boosting classifier also we are using. ADA boost. I am using just the default parameter. You can change if required. DT. And logistic regression. In logistic regression, let's change some, set some parameters. That is the class weight equal to balance. Usually it work fine when our data set is highly imbalanced. No? So class weight always work, gives some better result. Class weight. So you can define here class weight equal to balanced. And also someone will ask you question, then logistic regression work only in the binary class. How you can use this in the multi class? So one, they ask in the interview also, and I think when the trainer has taught you these topics now, they definitely informed you that logistic regression we can use in the binary class 0101, but we can use in the multi class also. Here if you write multi class is equal to 1 versus rest, 1 versus rest, we are passing this thing. Okay. Now write a basic function, simple function, so that we can use all these algorithms in one shot. So for model in.
Hello, sir. Hello, sir.
Yes, please speak.
One versus rest means one class versus rest class. Is it like that?
Correct. Okay, so it will print the performance of the model also. Then again print a line. And
So
afterwards,
do we need to separately import the other things like gradient boosting classifier, ADA boost classifier? Because my system
gradient boosting classifier, data boost classifier I have imported from the ensemble, sklearn.ensemble. Okay, it's just write all those things name. It will, you can import it. Yes, this I have used na. Ensemble, you can import all those things na. Random
Yes,
forest
yes.
bagging, boosting, all those things.
Got it.
So just fit extreme white train and just make a prediction. Y predict equal to abc dot predict x test. Then we can take the accuracy score and classification report, confusion matrix, whatever is required. So just I'm writing here classification report, nothing else. CR equal to classification report. Whatever you want, you can pass here. So this will be our y test, comma y predict. So classification report will come, and we can take the print of this print classification report, comma suppose I'm just printing this thing. You can write all other things also, and here whatever the model you want to pass, random forest bagging, all those things. Suppose I will write here this all random forest. Assume I don't want to use the random forest right now because it's already checked. In the bagging classifier, if you want, you can pass here whatever the new algorithms. Some base estimator you can change. If you want, you can change the base estimator. Whatever you will write here, it will take this only. Assume we want to use the, as a bagging, we want to use logistic regression. I don't think logistic regression will take or not, but you can write random forest, KNN, SBM, all those things you can write here. Okay, let me write here logistic regression. I don't know whether it will work or not. Let me check. Logistic regression I'm writing here. So again, I will pass here random forest, comma bagging, GDB, ADB, decision tree, logistic regression. All fine. Now let's run it. It's all fine. The performance of random forest classifier the same. It is giving the bad result. Whatever you have done. Tuple has no fit, has no attribute fit. Why? For the logistic regression, why it is saying like that? Bagging classifier. If I write here random forest, it will work fine. I hope so. Okay, because first it will ask whether it has been fit or not. That's the reason. If I write here at the end, it will work. Let me try. Log. No, it's not giving. The random forest will work.
You are not running it, sir.
Which?
Okay. No. Sorry.
It should work, no? Why it is not working? ABC equal to model dot fit. It should work. Why it is giving the error? No attribute fit. Fit. I've written fit. Yes, xtrain, ytrain. Model dot fit. Model dot fit xtrain, ytrain. Y predict equal to ABC. Why it is not giving the result? Bagging classifier again. Okay, no problem. Let me change it. Or I think I should have to write here. No. Mistake. Let me see what is written. You have to write estimator also. You have to write the estimator. Estimator equal to log. Let's see. No. This, and again I have to run this.
Sir, run this 130 line once again.
Yes, it's working. Yes, working. It's so. Look here, the little improvement it has shown here. No improvement, not much improvement. Recall here it is little better. For the ADA boost, it is able to read 1, 2, 3, 4 class. This class it is still not able to read. In the ADA boost, in the decision tree classifier, again it is not able to read these two class. Logistic regression, it's not able to read this one. This is the problem. Okay, so you can build this model like that. You can apply the, I'm just giving the assignment, I'm not using that part. You can apply the voting classifier.
Sir, you are doing the logistic regression, so we need to do first scaling, no?
I think scaling is not required, but let's see how the data set look like. This is our
Because
data set.
there are, yeah, there
The
are,
data set is DF, after doing all those things, DF2 now. Let's see here.
yes, sir, diff2.
Yes, if you want, you can do the scaling of, because this year is very high, description is also high in number.
Although, sir, description we have dropped, but year is still there. Year and
Yeah,
critical.
so these things you can drop. I think this year is also not required, because this is the this particular column is the this no
For
no
the,
variance column. This is the no
yeah,
variance column
no variance
everywhere.
column.
This, so you can drop this also. And description, if you, I don't think it is required. Description is not required. We have
So
already
we,
dropped.
yeah, we already
Description
dropped
already.
description.
This is also, but why it is not showing here if we have dropped DF2? Oh, X, in X we have dropped. In X, here we have dropped.
Yes.
Okay, so no scaling is not required, because I don't think that all the values are, the difference between all the values are less than 100. Okay, so
Okay.
you can apply voting classifier, stacking classifier, do the hyperparameter tuning. Okay, then by doing all those things, naturally our model performance will be little bit improved. Okay, now I'm trying, suppose this, first of all, try all those things and see which model is giving a better result. If you want to apply in worst scenario, suppose you want to apply the balancing approach.
So before balancing, we can also use the cross validation method also, and after
Yes,
the
cross
checking.
validation. Cross validation has no connection with balancing. Cross validation is the mandatory thing. So whenever you work on a data set, na, rather than relying on the trend test split, work on the cross validation approach. Because in the cross validation, we have n number of trend test data sets. Okay, so this is all different
Yeah,
thing.
okay.
Cross validation always in the real practice, we always do it. So now let's see how to balance this thing. So from balancing, we have to install, first of all, you have to install the IMB learn dot over sampling, import random over sampler. You can import the smooth also. The difference between the random over sampler and smooth is that in the case of random over sampler, it simply make the duplicate copy, but in the case of smooth, it creates the synthetic copy, means it follows the KNN approach. Borderland is better than smooth, because the limitation with the smooth is that whatever the nearest neighbors are there, whether it belongs to the same class, it or different class, it take the reference from this. So that's why the borderland smooth is developed. Okay, so it is better than the smooth. So let's use the smooth only. So smooth equal to smooth, I'm just writing random state equal to 100, no problem. And we will balance only our training data sets. So X train smooth, comma, Y train smooth equal to smooth dot fit underscore resample. And here we will pass X train, comma, Y train. So this is available with us. X train is smooth, Y train is smooth. This will be available. Run it. Now you can simple fit the model. Suppose I'm using the logistic regression. Just take the example. So log smooth equal to log dot fit. This time we will fit xtrain smooth comma ytrain smooth. So we have trained the data, trained the model on the balanced training data set. All fine. Now next is just predict y, predict smooth, y predict. Let's write logistic regression we are using, no problem. Is the log smooth dot predict, and here we will pass the imbalanced data set. X test is our still imbalanced data set we are passing here. We have done the prediction. Let's see what kind of accuracy we are getting. Is there any improvement or not? Okay, so print classification report, and here y test, y predict, sm log. No, why this performance has dropped? This performance has dropped because it's not the even same as. So what I have done is smooth equal to smooth random state equal to 100, no problem. Extend sm y10 sm smooth dot fit resemble. So we have done the smoothing there. Log is smooth equal to log dot fit extend sm y10 sm y predict log smooth equal to log dot fit, no problem. It's all fine. Log smooth log. So there is no need to redefine it again because already log we have defined. One versus rest. Okay. This is already we have defined here. No? This is the same thing it is taking. This. So balancing will not guarantee always a good result. So log smooth and then y predict sm equal to log smooth x test, y predict sm log y test is correct. If you're doing this thing. No, still it's not giving a good result. I think without balancing it was a better result. In the case of here, logistic regression, yes, but here the recall was less, only 30. It has improved the recall of this particular class, 41, but still it is not able to do a good result here. So I hope doing some this kind of hyperparameter tuning, we can find some better result. There is one another approach is there, anomaly detection. Anomaly detection. So let's try this thing from. Is the anomaly detection means finding the outlier. Ensemble. These all things are not in the syllabus Learnbay. That's why you have not out anomaly detection also. So this is the isolation forest. Isolation forest. In interview, they can ask question related to isolation forest also. If you are not finding a good result, what are the different approach you can say apply? So one is the one versus rest is also there. Isolation forest is there. In SBM also some approaches are there. I have not used the SBM. SBM can also you can try. It also gives some good result. I'm just writing ISO equal to isolation forest, and here we can see an estimator. By default an estimator is 100. Okay, maximum sample is auto. Contamination is also one part. Contamination is the rough estimate of the percentage of outliers in our data set. Okay, rough estimate. So contamination, it's one option. It is asking how many another class, minority class in our data set, approximate, tell me. So it is asking us. So look here, this is the situation. So basically we can say 74% plus 10%, 84% plus 7%, 92%, 99%. So 1%, 7%, this kind of situation is there, na? Minority class, because it's a multi-class classification. So it's always not, it's not easy to get accuracy on multi-class. So let's see here. It is asking contamination. So either you can pass the auto or you can pass some percentage also. So let's pass some percentage, or let it be auto only, no problem. Let's see, later on we can try, or if you want to change you can change it also. So make it change. So what is this industry by gender? Contamination. So contamination we can change to, let's make it 7%. Let's see, 7% or 9%. Just make it 9%, no problem, because I'm just considering 91% is our majority, and let's make it 9%. And also you can pass here random state equal to 50. Just run it. So we have these algorithms. Now just fit the model and let's see what can. But here the important thing is we cannot fit the model on the. This is not, you cannot make any kind of after fitting you cannot do some of the prediction. It's not used for the training the data set. This isolation forest basically we don't use for the training the data set. We are finding, just like as this is a good example of isolation forest in banking sector. Suppose you have taken a credit card from a bank. You have taken a credit card from a bank, and now after a few days, suppose you are getting a call from the bank. Are you making some kind of transaction of 10,000 rupees, 15,000 rupees? On what basis they are making the call? Why they are making the call? Because you belongs to Bangalore. Just take the example. Your hometown is Bangalore. You have taken the credit card for, because your hometown. So 90% time you will be use this card from the Bangalore only. Either online shopping, if you will do, then some specific sites will be there. If you will go to the market, some restaurant, some shopping mall, so 90% time you are using your credit card from Bangalore. Now assume someone is using your credit card from any other city, new city, like as Nigeria or some other place. So first, a suspicious things is this, that it is using from some different city. Second thing, you have never purchased this thing from a particular website, and this is doing this particular transaction from that website. Third thing, if the amount is so abnormal, most of the time you have purchased 10,000, 20,000, 50,000, and here it is making a transaction of something 80,000, 90,000, 1 lakh rupees. And the fourth thing, assume it is using your card for some kind of luxurious purpose, buying a mobile, booking a cruise. So these all things are abnormal activity. It's not normal. So they are considering all these things as an outlier. It's the outlier. That's the why that they have considered this activity as an outlier. It is not the common one. Your all transaction is like that, na? Your all transaction is like that. same city, amount is same. It's a multi-class. It's a multi-dimension. But this one is the something unique. This one is something unique, high value, different city, luxurious item. So it will consider it as an outlier. So here we are not handling the outlier. We are finding the isolated forest. These all are the forest. They are all are together. This one tree is isolated. So we are finding this kind of transaction. That's the purpose of isolation forest. So we can apply this thing here also. What are the normal? What is abnormal? This thing. These topics are really interesting, but we can't cover this in 15 minutes, 20 minutes of time. So that's the reason I'm just giving a brief idea. So ISO.fit, just fit it on our X. Just fit it on our X. You can see what are the different mod ISO. You can, if you want, you can see this also. 1 minute. Print. What are the different parameters are there? So ISO dot get param. First fit it. You'll find what happened. 9 state. Okay. The contaminant parameters must be among auto. The float is range of, okay. We cannot use this as a 9%. Maximum to 5% we can use. Maximum to 5%. No, I think it should be 9. No, 9% will be 0.9. It's not 90%. Okay, so these are all the parameters. Now
So why you use only X, not exchange?
Because it will here the Y is not required in the isolation forest. We just want to see the some this thing, na?
So this
That
is unsupervised learning, sir.
Yes, it's unsupervised learning. Okay, so we don't require that thing, right? So let me copy this.
सर X में हमने train और test दोनों ही डाटा दे दिया, बस ये तो पूरा डाटा है.
Only X I am taking. I am not taking the Y.
No, yeah, but you just put only on the X train and X test, both data, not only the dependent variable. So this is not for
taking the independent. I am only taking the independent variable. Na? X
yes.
is our independent variable. So it will like that actually. This is all our data. Okay. This is all the vectors. Multi-dimension vectors. This is one something suspicious. Just take the example. So if you run a normal model, it will not able to identify this. It's very difficult. This looks close to blue one, normal one, but it is suspicious. So how it works? It will create everywhere is dot are there, no problem, everywhere. So it will start creating like that. So, sorry, this is not good. So it will start creating the small box. It will start creating like that. More small box, more small box. So look here, this is together, no problem. This is together. If suppose here also dots are there, here also dots are there. But when it will found it's isolated, it will identify it. This is isolated. It will identify like that. These are together. Suppose some dots are there. This is also together. This some more dots are there. This is together. This is together. This is together. Okay. It can give some wrong sometime also, because this is suppose it is finding it is also isolated. So it will give you some wrong information. Yes, this is suspicious. This is suspicious. But most of the time it will identify whatever the suspicious activity, whatever the outliers are there. So basically what we are doing, we are just working on the independent variable. We are not using the dependent variable because it's the unsupervised learning approach. So let's create a column, because I have used this. Let's create a column in our, I've just make a copy of DF10 just for the learning purpose. So just create a column in the DF10, and here what we will do, we can find the decision function. So equal to ISO dot decision function. Decision function is also one. So let's pass here X. Then again create one new column, df10 anomaly score.
Go also, it should be DF10 on the go line.
Yes, df10 anomaly score. So in the anomaly score, what we are doing, we are predicting ISO dot predict. Yes, predict the score X. And here the result will become in the form of 1, and in the isolation forest, the result will become 1 and minus 1. 1 and minus 1. If any, if these things are normal, this is abnormal. By default, this parameter, this is the result will give always in this format. Okay, 1 and minus 1. Okay, so let's try. If you run this thing, yeah. So score, it is calculated. This also, let's run it. Now check here, df10 dot head. So minus one, this two, it is considering as a abnormal activity. These two transactions, first one and second one. It is considering as a abnormal activity. In all other, it is considering as a normal activity. If you want, you can check here how many it is considered as a abnormal activity out of all. So it's and this is the score value it has calculated. Dot.
Sir, how do we interpret this in terms of accident? Does that mean -1 means accident really happened?
Yes, it is
One,
finding it's the accident situation. It is considering as a accident situation, severity of the accident, and this is considering is not very much
not much
with respect
severe.
to all the- Yes. So here it is finding class 1, it is giving us 386, because isolation forest will give result in binary class only, it's not the multi-class. Okay, so in -1, out of this all the observations, whatever we have, some 400 and something in testing data set, na? In the X, so sorry, total number of observations, we have something 400 something. So 39 it is considering as a accident, and these are the normal.
So we can say, sir, 39 are work.
Yes, 39 is the anomaly, means it's something unusual, right? You can mostly use this thing in the credit card fraud transaction. That places most of the time we use, because in credit card or kind of fraud transaction, we don't have multiple options, na? That fraud is fraud, seems to be a fraud, chances of fraud. No, either it is a fraud or no fraud, either it is a disease or no disease. So that's why we can use this isolation forest in. It gives much better result when we use on the binary class. So this is also one way you can apply. You can take the help of isolation forest when your data set is highly difficult and you are not able to solve it. And the second part is the case one we have solved. Second one is the potential accident level. Okay, the same approach, same thing you can try on the potential accident level also, but for that I hope it will work better in the potential accident level. It works better because so you can try this thing. Let me apply one more thing. So this is the also assignment I'm giving. Assignment, please build the model for other dependent variable potential accident level. So you can try for this also. Please do it. Okay. And now we can use the SAP also. One thing is there na SAP. So let's try this SAP function. Okay. For the SAP, just create a. I'm applying this thing on the accident label for the SAP. Okay. So let's see how it will decide that what is the most important factor in the SAP. So I'm just writing one line of one function here. Then you can try by yourself again. So accident label okay, equal to what are there are different accident labels. Accident label. So we have accident label 1. We have accident level 2, 3, 4, 5. I think there are 5, 6 accident level is there. Okay, you can find there also DF. Where is this accident level? This is no. You can just check it. DF2. So SAP will having many other fun features, but this I am using just for the purpose of feature importance. So there are 4, 1, 0, 1, 2, 3, 4 categories are there. Okay, in the accident level, you can give any name, whatever you want. Okay, 0, 1, 2, 3, 4. So let's write in the same way. If it is accident level 0, comma, just assign it. One, 2, 3, 4. No problem. 0. Here we will write 1, 2, 3, 4. And the last one is the 4. So we have created a variable accident level that we can pass on when we build this thing. Now that we can pass as a class name. We can pass this as a accident level. Okay. Now next is the SAP.tree explainer. So SAP having one function, just like as explain equal to, I'm just giving a variable name, SAP.tree explainer. So it is giving you the explanation, the importance of these all those things. Okay, I am using here model equal to, just take the example, random forest. No problem. I'm using the model equal to random forest. Then any variable name you can write. Explainer dot shape values. Here you can write x equal to extend. Now summarize it. SAP dot summary plot. Here SAP values already we have decided. SAP value equal to SAP values SE. So these all things it will ask you if you just use this now. It will ask you just pass all those things. What is SAP values? What is feature? What is display? These things it will ask you. So simple. First pass the SAP values. SAP values is this SAP values dot AC. We have defined here. So all things are given in the parameters. Just you have to use how to use it. This is only the skill, and that's only they can expect sometimes in the interviews. Step values. See that we have already defined here. This is explained or this, and whatever you want. Suppose you want to. Yes.
Value it should be, not yes.
Okay. Yes. Correct. Step value SE we have defined, and features equal to xtrain. Features name is equal to